Hi, I'm Michelle Nguyen, and my drug is Pepcid, or known as famotidine. The brand name is Pepcid, the generic name is famotidine, and that is the chemical name. What the drug is used for. Pepcid, or famotidine, is an over-the-counter and prescription drug that is commonly used for the treatment of heartburn and ulcers. When you should not take the drug. If you have allergies to H2 blockers such as cimetidine, ranitidine, and nizatine, or if you have stomach cancer, chronic kidney disease 3A or 3B, or chronic kidney disease 4 or 5, significant interactions with other drugs. Famotidine is used to reduce stomach acid, so stomach acid must be present in order for the drug to work properly. Other interactions with other drugs are atazanavir, dasatinib, and dalredine. An interesting fact about the drug, it is also used for dogs to reduce stomach acid. Here, my molecular formula is C8H15N7O2S3. I am now going to show the skeletal structure of the drug. A skeletal structure is a shorthand representation of atoms and bonds in a molecule. There can be single, double, or triple bonds. In this structure, there are only single and triple bonds. The carbons are not shown but are implied by lines. Each line represents carbons on each endpoint. Hydrogen atoms are implied and are bonded to each carbon unless stated otherwise. Atoms that are not carbon and hydrogen must be specified in the structure, such as the nitrogen, sulfur, and oxygen. All the atoms want to have an octet, which means 8 valence electrons around them. And that is shown with the single and double bonds and the lone pairs. Here I'm going back in to add lone pairs to the atoms that need to satisfy their octet still, which is on the nitrogens, sulfur, and oxygens. Below, I will show the expanded structure. In the expanded structure, I will explicitly show where the carbons and hydrogens are. Here you can see me adding in the hydrogens that are bonded to the nitrogen. Now I will also go back and show where the hydrogens are bonded to the carbon. I'm now adding the hydrogens to the nitrogens. I'm also adding the nitrogen that's bonded to the carbon and the hydrogens that are bonded to the nitrogen. In this structure, I will also go back in and add the lone pairs to the atoms that need to satisfy their octet. Now I will show the molecular geometry of each central atom. The bent structure will be represented by blue, which can be 2 bonds in 1 lone pair or 2 bonds in 2 lone pairs. Next, I'm going in and showing tetrahedral, which is 4 bonds in 1 lone pair. Next is the orange, and it is 3 bonds and 0 lone pairs, which is trigonal planar. Next is trigonal pyramidal, and that is represented by 3 bonds and 1 lone pair, and that is the purple.